So remember on one of the worksheets you turned in, you had to multiply. And let's say it was this problem. I'm just going to do one problem. Let's say it was 4 times 3x squared. Let's just do 4 times 3x minus 5. And if you were to multiply this, what would you do? You distribute. So I get 12x minus 20. Okay? Now, notice that this first expression that I'm pointing to, that's a product, right? And when we talk about products, if I have something like 8, and we know that 8 is 4 times 2, 4 and 2 are called factors. So a factor of 8 is what? 4. A factor of 8 is also what? 2. I can also say 1 times 8. A factor of 8 is itself, isn't it? So 8 has several factors. So the factors of 8 are 1. 1 goes into everything. 2, 4, and itself. So those are all factors of 8. All right. But this one in particular right here, so when I have 8 written as a product, 4 and 2, so each of those are called factors. So if I look at this right here, for this expression right here, this product, 4 is a factor. And then what's the other factor? What's the other factor that you see?
What's the factor of 4?
No, that's not what I asked. Read this to me.
4
times
3.
3x minus 5. So I said 2 things. How many things are being multiplied together? 2. 2 things are being multiplied together. The 4 and the what? 3x minus 5. Isn't that how you got this? You said 4 times what? 3x minus 5. So how many factors do you see? 2. That's going to be important when we go into that factoring. Okay? You have to be able to recognize the structure of these things. So 4 is a factor, and what's the other factor? 3x minus 5. Because when you read it as 4 times what? 3x minus 5. So those are 2 things being multiplied together. Just like when you do the 2 binomials. Remember when you did the 2 binomials? 3x minus 2 times x plus 5. Why'd you use the FOIL method? Why'd you use the FOIL method on that one? Not because you're supposed to. Because you're multiplying 2 binomials together. You're multiplying 2 binomials. 2 things. What are those factors? What's one of them? 3x minus 2. What's the other? X plus 5. So when we start factoring trinomials, you're going to write it like this most of the time. Those are factors. You have to. So it's going to say factor. That's going to be the directions, factor. So when you factor, you want to know, you want to rewrite these things as products. Okay? So, okay, you can use that as a generalization. Factor means to write as a product. So if I look at this problem that I just wrote right here, that 12x minus 20, and I ask you to factor that, basically you're going backwards. You're going backwards. So I want to go from 12x minus 20 to this. Factoring, if you want to think about it as a generalization, means to write as a product. So you got to look at how many terms you have here, though. Now notice I use the word factor and I use the word terms. This expression right here has how many terms? We talked about terms before. 2. They are what? 12x and what? Negative 20. So when you factor, you look at those 2 terms first and you ask yourself, what do they have in common besides the number 1? 4. 12 goes into, 4 goes into 12 and 4 goes into what? 20. So when you factor, you first of all look for the GCF. The GCF. So the first step is to always look for the GCF. That's the first step in factoring. So if I look at 12 and 20, what's the largest, the greatest common factor that 12 and 20 have in common. Now, 2 is a common factor, right? 1's a common factor, but that's not the largest. What's the largest? 4. Hence, you saw the 4 right here. So what you're going to do is you're going to take that GCF and you're going to write as a product, multiply by something to get the original back. Okay? That's basically what you're going to be doing when you factor in this section. So if you know the GCF, then the rest is easy because it's just the distributive property. 4 times what is 12x? 3x. Minus 4 times what is 20? 5. And that's your answer. You factored. So factoring means you take that polynomial and you're going to write it as a product. Because that's what we said with 8. 8, if I write as 4 times 2, the 4 and the 2 are called what? Factors. Okay? All right. Now, I'm hoping that all of you were able to tell me that the GCF of 12 and 20 is 4. Okay? The GCF of 12 and 20 is 4. If you did not know that, then one of the things you can do to determine the GCF is find the factors of each one first. So we can list the factors of 12. The factors of 12 are, and you just go through your whole numbers. The first whole number is 1. 1 always goes into a number, so that 1's always a factor. So 1. 2 goes into 12 because 2 times what? 6 is 12. Hey, I said 6, didn't I? So isn't 6 a factor? Yes. What about 3?
3.
Yes. So I can say 3, and what else is a factor then? 4. And then there's only 1 left. What is it? 12. Because I said 1, didn't I? 1 times what? 12. So that's one of the ways you can find your factors. Now let's talk about the factors of 20. What are the factors of 20? Well, there's 1 and what? 20.
2.
There's 2 and what? 10. There's 4 and 5, and that's about it, right? All right. Now, there's some common factors here, aren't there? Like, what are some common factors? 1's a common factor of the 2. 2 is a common factor of the 2. 4 is a common factor of the 2, and that's about it, isn't there? GCF means the greatest. So what's the greatest one? 4. So the GCF, so 4 is the greatest one. So the GCF of 12 and 20 is 4. So if you cannot tell right away what the GCF is, then one approach is to list the factors of each. And then the greatest one will be the largest one they have in common. Okay? There's another way to do this. And in some cases, it may be easier to deal with. So let me show you the other way. You learned this in a previous course. It's called factorization. Prime factorization. Remember the factor tree? You may remember the word factor tree. Okay, so let's go back to 12. Let's look at 12. So 12, I'm going to break it into a tree. So 12 is 2 times what? 6. And basically, you're looking to rewrite this in terms of prime numbers. So remember, your prime numbers are 2. What's the next one? In fact, the only even number that's prime is 2. 2 is the smallest prime number. 1's not a prime number. 3 is a prime number. Remember, prime numbers are numbers whose only factors, remember the word factor? Whose only factors are 1 and itself. 5 is a prime number because the only factors of 5 are 1 and 5, right? What's the next one? 7. Next one. Nope. 9 is not a prime number because 3 goes into 9. 11. Next one. 13. Next one. 17. 19. 19's prime. 23 and so on. They're an infinite number. Okay? So those are your prime numbers. So when you do the prime factorization, when you do that factor tree, when you split into little branches, consider those little branches, 2 times 6. Could someone else have said 4 times 3? Yeah, someone else could have said 4 times 3, does not matter. But then look at the ends over here and see if you have any that are prime. Any of these prime?
2.
Circle it. That means you're done with that branch. Over here you would circle which one?
3.
3. Over here, 6 you can write as what?
2 and 3.
2 and 3. And both of those are what?
5.
So I'm done with this one. Over here, that's what?
2 and 2.
And I'm done. So 12 is 2 times what?
3.
Times 3. Y'all agree? And let's do 20 now. 20, you're going to say 10 times what? 2. 2 is prime. 10 is 2 and 5, and those are prime. So 20 is 2 times 2 times what? 5. Y'all agree? Okay. So notice it's a little bit different than this one, right? So the approach here, which is a list of factors, the approach here is to write these as prime factorizations. And basically you want to circle all the factors that they have in common. I'm going to circle the pair of 2's here. I'm going to circle the pair of 2's here. Do I circle a 3? No, because there's no 3 here. Do I circle a 5? Nope. So 2 times 2 is what? 4. So you can do it that way as well. Okay? No, but that's not always going to be the most feasible one. You got to learn both ways. The other thing I want you to do is for right now is this, because that's going to be important when we talk about the variables. Right now we're only talking about numbers, right? We're going to talk about variables. Do y'all also agree that 12 is 2 times 2 means 2 squared, right? Okay, 2 squared times 3. And 20 is 2 squared times 5. Okay. So that's going to be important when we get into the variable. I'm going to come back to this. All right. But if you notice, the same idea is 2 to the second power what they have in common?
Yes.
And what's 2 to the second? 4. Okay? All right. So let's do a couple more with numbers. Let's look at find the GCF of 40 and 48. Find the GCF of 40. And 48. All right, we're going to do it both ways, and then I'm going to stop doing both ways, and I'm just going to use a factor tree after that. All right, so the factors of 40. Now you got to be careful when you do it that other way, because you could miss something. So that's something you could miss when you list the factors. You could miss some, whereas when you do the factor tree, there's no way you can miss any.
So the tree's your safest bet.
The tree would be the safest approach. So if you list the factors of 40, the factors of 40 are 1 times what? 40. Now guys, I'm not saying 1 times 40. I'm saying 1 comma 40, right?
Right.
Because I'm listing the factors. 1's a factor. What else is a factor? 40. Now give me another factor of 40. 2. Let's go from smallest to largest. 2 times what? 20. So 2 is a factor. What else is a factor? 20. What else is a factor? 4. 4 times what? 10. What else is a factor? 5. 5 times what? 8. And I think I've taken care of all of them. That is, listening like this, you can easily miss some, especially if the numbers get bigger, right? All right, let's do 48. Factors of 48. 1 and 48. 48's even, so I know 2's got to go into it, right? 2 and 24. 4 and 12, right? 3 and 16. Use your calculator if you need to. So you said 3, right? So 48, look, 48 divided by 3 is what? 16. I could be missing some. 6 and 8, okay, good. And that's it. All right. It's a little bit more difficult to do when the numbers get larger. So of those factors that are listed, do you see a larger one they have in common? 8. So what's your GCF? 8. So the GCF of 40 and 48 is 8. Okay, so when you factor those trinomials, the first thing you have to do is look for a GCF. And so that's if you can't look at 40 and 48 and say the GCF is 8, now be careful. Don't say the GCF is 2. That's a common factor. Don't say the GCF is 4. That is a what? Common factor. You're always looking for the GCF. G means greatest. So what's the greatest common factor? 8. If you do a factor tree, so if for some reason you cannot look at those numbers and determine what the greatest common factor is, then do the factor tree. Okay? So give me two numbers whose product is 40. That's what you do. Give me two numbers whose product is 40. 4 and what? 10. Someone else could have said 2 times 20. Someone else could have said 8 times 5. Does not matter, right?
Right.
Do I circle any of those?
No.
No, because none of them are prime. Let's do the 4. 4 is what?
2.
I can circle those. 5 is what?
5 and 2.
5 and 2. I can circle those. So 40, right now, I know that 40 is 2 times 2 times 2 times what? 5. Okay, now let's do 48. Give me two numbers whose product is 48. 6 and 8, that's true. I can use 6 and 8. Someone else could have used any two other numbers, right? Whose product is 48. Is 6 prime? No, I can go further with that. 6 is what? 3 and 2. Circle those. 8 is what?
2 and 4.
4 and 2. Which one can I circle?
2.
2. And then 4 is what?
2 and 2.
2 and 2. And I'm done, right? So 48 is, and put them in order, 2 times 2 times 2. Always put them in order because that's going to help you. And notice what I'm doing. 2 times 2 times 2 times 2 times 3, right? Okay, I'm going to circle the common factors. Here's one set. Here's another set. Here's another set. And that's about it, right? So that's 2 times 2 times 2, which is 8. Okay? All right. It helps if you know how to do both ways. It does help. All right? Now, I'm sorry? They don't have 5 in common, so that's not going to be part of it.
Looking for the 5.
It's right here.
Okay.
All right. Now, let's go ahead, though, and write it like this for right now, because that's going to help us when we get into the variables in a little while. 40, I can also write as 2 to what power? Third. Times what? 5. Okay. 48, I'm going to write as 2 to the, the 4th. Good. Times what? 3. That's going to help us in a little while when we do variables. So we're going to come back to this right here in a little while. All right, let's do one more. Let's do find the GCF of, so it's number 3, I guess. Find the GCF of, this time we're going to do 3 of them. So in the worksheet there's 1 or 2 problems where there are 3 numbers and you find the GCF of those 3 numbers. But it's the same approach. 44, 64, and 100. 44, 64, and 100. And if for some reason you're not just looking at those 3 numbers and you can't determine what the greatest common factor is, then just use a factor tree. Let's do 44. 44 is what? Make things easy yourself.
2 and 2.
4 times 11, right? 11 is prime, and 4 is what? 2 and 2. So 44 is 2 times 2 times what? 11. So that's prime factorization. It's a prime factorization. Remember the word factor? It's a prime factorization because I wrote 44 as a product of prime numbers. All these are prime numbers, aren't they? So that's prime factorization. You remember that word from a previous course. 64. 64, 8 times 8. Okay, I'll go with 8 times 8. 8 is 2 times 4. I can circle the 2. The 4, though, is what? 2 and 2. 8, go back to the other 8 now. 8 is 2 times 4 again, right? And then the 4 is what? 2 times 2. So the only things I have circled is what number? 2. And how many are there? 6. So you're going to say 64 is 2 times 2 times 2 times 2 times 2 times 2. Just like that. And then finally 100. Now before I go on, let me ask you this. Of those two numbers, what's the GCF? 4. Who said 3? I thought someone said 3. GCF is 4, isn't it? Just those numbers right away? Because 2 times 2 is what? 4. That's what they have in common. But let's do 100. 100 is, what do you want to try? 5 and 20? Someone else could have said 10 times 10, right? 5 and 20? Yep. 5 is prime, and then 20 is what? 5 and 4. You could have said 2 times 10 does not matter. You would still get the same answer in the end, right? So 20 is 5 times 4, and 4 is 2 times 2. So 100 is 2 times 2 times 5 times 5, right? And then notice, if you look at those three numbers, what factors do they have in common? They have a set of 2's, and they have another set of what? 2's. So it's 2 times 2, 4. So the GCF is 4. Okay, so that's how you find the GCF. All right, now I'm going to go back and I'm going to write 44 as an in terms of exponents. So it's 2 squared times 11. 64 is 2 squared, 2 to the 6, right? And then 100 is 2 squared times 5 squared. All right. We're going to come back to that in a little while.
2 to the 6, that's it.
2 to the 6. Okay, so any questions on finding the GCF of numbers? These are the factor tree. Okay, now, let's look at this one. This is going to be number 4. Find the GCF of y squared, y to the 4th, y to the 5th. Find the GCF of y squared, y to the 4th, y to the 5th.
Y squared.
So you think the GCF is y squared?
No.
Yes.
No, that's the one.
Why?
It's y
Because all
squared.
their exponents are different.
Okay, so remember in the word GCF is a word common, right?
Yes.
So whatever you pick, whatever you say the GCF is, that factor better go into all of them.
It's y squared.
So if you don't think it's y squared, what would you think of? 1? But you have variables here, so you got to use variables.
Y squared.
Y squared?
Yes.
Okay. Now, does y go into all of them?
Yes.
Yes. But is that the greatest one?
No.
That's just a common one. So what's the largest factor you think that goes into all 3?
Y squared.
Y squared. So you may say, now here's what you're thinking about probably. You may say, well, and the word GCF is the word greatest. Why am I not using the largest exponent?
Because
Right?
they're not common.
Well, let's go back to these right here. When I asked you, now right here, we said the GCF is 4, right? 2 times 2, 2 times 2, which is 2 to the 2nd power, right? Okay? So this is not really a good example because both of these had 2 to the what? Second power. There were no other 2 in there. So that one was obvious because they both have factors of 2 and both their exponents are the same. What is it?
Two.
2. So it's going to be 2 squared. Okay? Now let's look at this one. Here, this was the 2 times 2 times 2 is 2 to what power?
Three.
To the third. All right. So in one of them, I had 2 cubed. In the other, I had 2 to the fourth. But I had to use the one that had the smallest what? Exponent. So the GCF, when you write them as exponents, the GCF is going to be the one with the smallest exponent. You can't use 2 to the fourth because 2 to the fourth does not go into 2 cubed. It's too big. Because 2 to 2 cubed is 8, right? And 2 to the fourth is what? 16. So I'm going to ask you this. Does 16 go into 8 or does 8 go into 16? 8 goes into 16. So always use the one, the smallest exponent. Okay? So I'm going to go back over here now. I'm going back over here. When you're dealing with variables, and all these variables have the same base, they're all, what's the base in all of them? Y. The GCF is the one with the smallest exponent. You cannot say y to the fifth because y to the fifth is not going to y squared. Y in the fifth is not going to y to the fourth. But y in the fifth goes into itself. So it's one of the smallest exponents. So the GCF is what? Y squared. All right, let's look at number 5. X squared y cubed, comma, xy to the fourth, comma, x to the fourth, y squared. You're going to have, in your expressions, you're going to have 2 variables. We're going to find the GCF of those 3 terms. 1, 2, 3. The GCF, remember, in the word GCF is the word common. Do we have an x in common in all of these? Yes. Do we have a y in common? Yes. So my GCF, I'm going to have at least one factor of y and one factor of x. Okay, now here's the question. How many x's do I need and how many y's do I need? Well, let's go back and talk about what we did here. We always choose the one with the what? Smallest exponent. So let's talk about the x's. How many factors, I'm using the word factors, think of the word factor now. How many factors of x do you see here?
2.
2. X times x, 2. How many factors of x do you see here? 1. How many factors of x do you see here?
4.
I need how many?
1.
1. Okay, so x to the first, so just x. Let's do the y's now. How many factors of y do you see here? 3. How many here? 4. How many here?
2.
How many do I need?
2.
2. So what's my GCF?
XY squared.
XY squared. That's your GCF. So that's how you deal with the variables. So you deal with constants. You're gonna think of constants a little bit different than variables. Number 6. All right, here we go. Suppose I have 30y cubed, comma, 20y squared. 30y cubed, comma, 20y squared. Now this time I do have a coefficient, 30 and what? 20. Those 2 guys are easy enough to where you don't need to list the factors and you don't need to list a factor tree. I think all of you can tell me what is the largest common factor that 30 and 20 have?
10.
10.
So 10 minus
10, right? Not 5. 10 goes into 30 and 10 goes into 20. So far my GCF is going to be 10 and then now the variable y squared. That's your GCF. Now those of you that said 5, I'm hoping you realize that that was not correct, right? Okay. 10 is the greatest common factor of 30 and 20. Number 7. All right, suppose we had this. Suppose we had 66yx, comma, 30x squared y. 66yx, comma, 30x squared y. All right, GCF. Let's start with 66 and 30. What do you think the greatest common factor of 66 and 30 is? 3. 3. If you weren't sure, then do the factor tree, right? Let's do 66. 66 is 3 times what? Or let's do 6. 6 times what? 11. Right?
Yeah.
And then 6 is 3 times what?
2.
2. So 66 is 2 times 3 times 11. Y'all agree?
Yes.
All right, let's do 30. Oh, it's not 3, it's what? 6. Thank you. All right, 30 is 10 times what? 3. And then 10 is what? 2 and 5. So 30 is 2 times 3 times what?
5.
So a 2 and a, what else is circled?
3.
So 2 times 3 is 6. So that's your GCF. So it's not 3, excuse me. It's what? 6. All right, 6. Okay, 6. Now you see, sometimes it's helpful if you do the factor tree. All right. Now, let's do the x and the y's. Do I have x's in both terms? Yes. So I'm going to need an x, at least one, right?
Yes.
How many do I need, though?
1.
1. Because how many factors you see here? 1. How many factors you see here?
1. 2.
2.
That says 66y.
What now?
That says 66y.
Yes.
Okay.
What about your y's?
1.
1 here. How many here?
1.
So how many do you need?
1.
1. So what's your GCF?
6xy.
6xy. Very good. All right, number 8. All right, what if I had 80 x cubed, comma, 30 x squared y? 80 x cubed, and then the other term is 30 x squared y. What do you think the GCF is? Let's start with 80 and 30. What is?
5.
No.
10.
10. 10, right?
Yeah, 10.
Okay.
10x squared.
All right. And then let's talk about the x's. Do I have x's in both terms?
Yes.
How many do you have here?
3.
How many do you have here?
2.
How many do you need?
2.
2. Very good. Do I have y's in both terms?
No.
So am I going to use any?
No.
Nope. So what's your GCF?
10x
10x squared. Okay. All right. Number 9. See, it's not that difficult. So we're about to use those, though, in factoring. You have to know things about the GCF in order to factor some of these polynomials. All right, so let's suppose we had this. Suppose we had 140 in, comma, 140 m squared, comma, 80 m cubed.
20. 40.
60, 80.
Dude, if you're going to guess that many times, what I would have done is just do the factor tree.
20.
First of all, am I going to have any variables in my GCF?
Yeah, no.
No, because are there n's in every term?
No.
Are there m's in every term?
No.
No. Now let's talk about the coefficients. So 140 is 10 times 14, and then 10 is 2 times 5. 14 is 2 times 7, right? So 140 is 2 times 2 times 5 times 7. Y'all agree?
Yeah.
All right, let's do 80. 80
2 times
is 10 times 8. You could say 2 times whatever. I chose 10 because the last digit was 0. 10 is 2 times 5, and 8 is 2 times 4. But I can do 4 further, right?
Yeah.
2 times 2.
Yeah.
So all these are now what? Prime. So 80 is 2 times 2 times 2 times 2 times 5, right? So let's circle the common ones. I can circle this set, I can circle this set, and I can circle this set. Y'all agree?
Yeah.
You see what I did? So I have a 2 times a 2, and what else? A 5. So what's my GCF? 20. 2 times 2 is 4. 4 times 5 is what? 20. So the GCF is what? 20. Okay. Out of curiosity, suppose I had this. Suppose I had 5x, comma, 3y, comma, 14x. 14x. That's 14x. Oops. All right. 5x, 3y, 14x. What's your GCF? 1. Don't say there isn't any. There's always a GCF. If they have nothing in common, there's something in common. It is what? 1. Okay. All right. So that was discussing GCF. Okay. So you now know how to deal with the variables, and you know how to deal with the constants, with the coefficients. There are 2 ways you can get help with this. You can get help using a factor tree, or you can list the what? Factors. You can list the factors. Okay? All right. So any questions at this point? Okay?